Thank you, Nathan and Bill, for accepting our invitation. So welcome everyone to our C2M2 Distinguished Speaker Series. So Charlotte Riggs, Miss Charlotte Riggs, who is our coordinator, will introduce the speakers. Thank you.
Yep. Thank you everyone for joining us. We appreciate you tuning in this Friday. We're going to go ahead and get started with Dr. Bill Ferrell and Dr. Nathan Huynh, Freight Logistics and Intermodal Network Design. If you have a question at any point in time during their presentation, feel free to put it in the chat box. We will be monitoring that. And then after their presentation, we will have a question and answer session. So at that time, once they finish presenting, you're able to unmute yourself and ask the question directly. Or again, if you want to put something in the chat, we will go ahead and read that out for you. And with that, I'm going to go ahead and turn it over to Nathan.
Thank you, Ronnie. Thank you, Charlotte. My name is Nathan. I will be presenting alongside my colleague, Bill Ferrell. And I should point out that the work that we're presenting today is the work that was actually done by our PhD students. So we have Michelle at Clemson, and we have Bhavya and Fahim, my PhD students at USC. So today we'll be presenting a topic that's not very commonly known in transportation. It deals with freight logistics, and this is something that we feel is very important. Bill and I have been working on this topic for a long time, and we hope that you find some of the information that we're presenting here today useful, and that you're able to incorporate that into your own research.
Yeah, hi, I'm Bill Ferrell, and I'm a faculty member in the Industrial Engineering Department at Clemson. I've been here for quite some time with a background in optimization and modeling. Wanted to point out my background is not IE, which is a little typical is typical of some IE faculty. My background is in physics and nuclear engineering before I got my PhD, and I worked 7 years full time in the commercial nuclear industry. So I bring a relatively practical bent to my research, which matched well with Nathan.
Yeah, I also have some work industry. Since my dissertation dealt with port operations, I went to the Port of Houston quite often to collect data for my work, and so they offered me a job. So actually, I started working at the Port of Houston before I complete my PhD degree. So what should have been another semester worth of work drag out for 2 years. So don't make that mistake if you're graduate students. Currently, I'm a professor in the department. I also serve as the undergraduate program director and also ASCE faculty advisor. And I've been here at USC since 2008. Okay, so in this talk, you may be wondering how the collaboration between Bill and I came about. So we want to discuss a little bit about the shared interests or commonalities between industrial engineering and civil engineering. Then I will discuss why freight logistics is important. And then the bulk, a good chunk of our presentation today will focus on explaining to you how freight logistics work and what are some of the challenges facing the current freight system. And then we'll get into the work that our students have been doing along with us, focusing on three aspects or thrusts. Network design, our focus has been on identifying the optimal location for intermodal container terminals. The second one is mode of operation. We've been looking at ways in which carriers can collaborate to maximize revenue. And third is communication, how we can leverage the current communication technologies to improve cross-dock operations.
So industrial engineering and civil engineering are different in many ways. But interestingly enough, there's an overlap that is in transportation. And the way industrial engineers get at that is through supply chain and logistics and warehousing that naturally involves transportation. As I said, my PhD is actually in operations research, and so I've been in the logistics space for some time. So as you'll notice when Nathan describes kind of how he came at this, we had a natural overlap in application domain. And different methodological tools in some regards, which has made, in my opinion, an extraordinarily interesting collaboration for the last few years.
Yeah, so if you're a transportation student at a graduate level, you may have taken a course called Network Design Analysis or Intermodal Freight. And as you know, the methodology is mainly operations research, including simulation. And so that's how I got to know about this particular area, and I got interested. As a student at UT Austin, I took many OR related courses at the Industrial Engineering Department and also the Management Science Department. So if you are a graduate student in transportation, I highly recommend that you consider taking these courses at the respective departments. Okay, so think for a moment, why is freight logistics important? Okay, so is it A, it increases the value of goods by moving them to locations where they're worth more? So think of eBay, okay? On first point, think of eBay. Every day, thousands of transactions happen on eBay. That it involves shipping the goods from the seller to the buyer. So freight logistics is what allows the seller to make a profit by selling goods on eBay. B, or is it B? It encourages competition and production by extending the spatial boundaries of commodity and labor markets. So think of Apple. How would the freight logistics system is what allows Apple to compete with the likes of Samsung, for example. Or is it C? Stimulates demand for goods and services and employ millions of people. So think of Amazon. When was the last time you ordered something from Amazon, for example, right? If you're like me and most people I know, we get deliveries from Amazon almost on a daily basis. Why? Because it's so much cheaper and so much more convenient than going to the stores. Or is it D? It contributes to our nation's wealth and productive capacity. So think of the transportation system between a developed country and a developing countries. Right? That's what this, the freight is a crucial component of that, and it relies on the transportation system. Or is it E, or the above? Okay, so I hope you agree with me that is really all of the above. Okay, so how does freight logistics work? So to illustrate how it works, I'm just going to take you through a simple scenario where Amazon and Home Depot and Walmart and the likes of those companies bring in goods from East Asia to your home here in South Carolina. Okay, so how does the good get from East Asia to here? It gets boxed and stored and loaded onto a container and then loaded onto a container ship as shown here. And that ship will traverse through a set of ports. So here's a sample service from a steamship line called Mediterranean Shipping Company. And on the left figure there on the map, you see that basically this service here will visit 4 ports in China, and then it makes its way to Busan in South Korea, and then it goes through the Panama Canal, and then will hit several ports on the East Coast. Okay, and one of the ports on the East Coast here is the Port of Charleston. Next slide. Next, when I get to the Port of Charleston, it will end up at this terminal right here called Warner Welch Container Terminal, and this is where the containers get unloaded from the ship, get stored in the container yard, and then at some point it will get picked up by a truck. Okay, and so I'm just going to walk you through the Amazon process. The container will then get picked up by a truck and then bring it to an inbound cross dock. The inbound cross dock is usually located near a port or rail yard or an air hub. Once the container gets to the inbound box, it then will get unloaded and get transferred to the Amazon e-fulfillment center. And at the e-fulfillment center, this is where the goods get stored and assembled for individual online orders. At any given time, you have exchanges between the Amazon e-fulfillment center and the sortation center. And this can be done by air if it's a long distance and high commodity, high value, or it can be done by a third-party logistics provider or by USPS. Okay, and then at the go back, Bill. So at one of the sortation centers, typically what they do is they sort the parcels bounded to smaller areas, for example, zip code, and then once at the sortation center, it will get delivered to. If it gets delivered by USPS, it will go eventually to a locker or your home. Okay. Next. I mentioned about cross dock. So this is what a cross dock does. A cross dock is where basically you have inbound trucks on the left-hand side there. Each inbound truck brings in one specific type of commodity, and the cross dock itself, you get goods being sorted and then loaded onto the outbound trucks. As you can see on the right hand side, the truck would then be loaded with multiple commodities and destined for the different retail stores like Walmart or Home Depot and such. Next, here is a map that shows where the Amazon e-fulfillment center is as of 2015 or so. As you can see here in South Carolina, we have a couple of e-fulfillment centers. So we have a short video just to show you what an e-fulfillment center looks like, how it works on the inside. So Bill's gonna run that. It's a 2.5-minute videos, but we're just gonna show for about 30 seconds. So this is, so we have one here in West Columbia. If you, they do tours right now, not right now, but maybe once the pandemic is over, you can do a tour of these facilities and see how that works. It's pretty cool. I don't remember where in the video, but basically once you make an order, they have this robot that basically takes the goods from a rack to a place where there's a person that basically pick up the item from that rack. They put it into one of these totes right here, and then off it goes into the right area to be loaded onto the truck. And this is what I'm talking about, the robot here. Yeah. Okay, we can stop there, Bill. Okay, next. Okay, so what are some of the challenges with the current freight system? You see in the next slide here, I'm showing you how the ship size has increased. And this is all due to the global recession that started in 2008. And at that time, the steamship lines or ocean carriers did what was once thought of as unthinkable, which is to partner, to collaborate. So due to recession and academics forced steamship lines to say, you know what, okay, I have lots of empty spaces on my ship. I'm gonna rent out these spaces to my competitor. And that led to this evolution of bigger ships. They found that it was much more economical and beneficial to have one ship instead of having two ships going to the same port. So that led to this evolution of what we call mega ships. Okay, and the size of the mega ship, go back, the size of the mega ship, you see how big it is this humongous. Okay, so it carries up to 18,000 TEUs. That's roughly more, that's typically more than 10,000 containers off a ship. So that's really big. So the size of the ships will force the ports authority and the terminal operators to basically buy larger cranes. And we're talking about millions of dollars here for each one of these cranes. They need to have a longer and stronger berth and also deeper and wider channels. Okay, and then also at the state and regional level, these agencies will also have to have deeper and wider channels and also greater air draft. So greater air draft meaning that the bridge has to be built at a higher elevation. Next. Also, the volume that comes from these mega ships will create surges, and that creates more complications for the terminal and port authorities. So specifically, they would need to improve their yard surge capacity, improve their throughput and turn time, increase their drayage and rail capacity, add additional off-dock facilities, and then also improve coordination between the carrier, the terminal, the drayage companies, and also the beneficiary cargo owners. And at the state and regional levels, the mega ship volume will require these entities or agencies to add off-dock facilities, increase the port connector capacity, and also improve the communication flow between all these entities. And next, and now Bill is going to cover the changing nature of freight.
Right, and as Nathan has described, kind of a typical supply chain to get products from one continent to another and into the retail stores or delivered to us. At the end of this section of our presentation, I'll tell you that the punchline. Punchline is we are at the precipice of a huge mess, and collaboration looks to be an opportunity for us to avoid this becoming worse than it has to be. So as you're looking at this, be thinking my point is that freight's going to be changing, volume is changing, the way we currently handle things is going to be inadequate, and we're going to have some type of paradigm shift in the freight transportation and logistics network. So now that you know the end, and we're at the beginning, let's get from here to there. 20 years ago, when I still had hair and was carrying a club, we did things kind of a particular way. We made stuff in large volumes. We had big factories. Frequently, they were in more rural areas for low labor cost. We packed these things in boxes, put them on pallets, shipped them to stores where you and I wandered in to pick this up. Now, for those students in the group, you may not believe that we ever went to stores to buy stuff. And as Nathan said, I'm with him. I get stuff delivered from Amazon all the time. But it wasn't too long ago that I actually drove and parked and walked into a store and bought stuff and brought it out. Caveman years. Back then, there was a focus on efficiency. We have these large distribution centers, and the picture we showed you for Amazon is not quite a distribution center, but what you saw in there, all the automation and stuff flying around, is sort of what a distribution center does, but the focus is on very high density storage and moving pallets very efficiently. And Nathan's already mentioned cross stocks. Well, that's cross stock was an invention of Walmart in order to make this transporting pallets very efficient. And Walmart literally has been a world-class company based almost entirely on supply chain efficiency and optimizing the supply chain. The point now is that this is the system we are living with. This is what we're doing right now. That's the one that's delivering the goods right now. But if we look forward, maybe you don't even have to look 20 years out when we'll be riding along with the Jetsons. Just like now, you know that stores and malls where we used to go and Barnes and Nobles have been replaced by Amazon and Alibaba. So fundamentally, without any deep scientific or engineering knowledge, just from our personal daily experiences, we know that things are changing. There were some pretty cool ideas, right? Amazon's done lots of stuff, but however how many years ago they came up with Amazon Prime, that was brilliant, right? It was this idea of paying a little bit and you would get shipping for free, and it would encourage people for the convenience. And then all of a sudden they said, well, we can do this in 2 days. As you might expect, companies like Walmart, they're not going to take that laying down. So Walmart says, well, we can do it in 2 days as well. And oh, by the way, we don't have any membership fee. And what does Amazon say? Well, we'll see your 2 day and we'll raise it to 2 hours. And then, well, Amazon says, gee, we don't have to deliver it to your house if you aren't there. You can pick it up in the lockers you're coming home from school or from work. Or we're looking at little drones. And so there are these really cool, competitive business ideas that are changing freight. And fundamentally, I would contend, and I hope you will eventually accept, that there are 3 elements to how they're changing freight. One is the emphasis on direct to customer. The second is this ever shortening lead time between when we place an order and when it arrives. And then the third one you may not have thought about, but you now know that we have the Amazon does its thing, but then you have the Amazon marketplace and you have all these people that are affiliated with Amazon, and the same thing for Walmart, the same thing for Target. So we are getting lots and lots of small e-commerce businesses being spun up that are affiliating with the big folks, but they are little independent businesses. So the key concept behind all of this is that freight's changing and freight transportation must change as well. So this was the motivation for the work that Nathan and I and our students have been doing. So what's the nature of these changes? Because if we understand the nature of the changes, then there's a chance we have an opportunity to do some work to to mitigate the impact or to allow it to continue to work as efficiently as it has in the past. So the first thing is retail is continuing to increase. This is just some data I grabbed from a report that was based on some U.S. Department of Commerce data. And I don't really care how you interpret, how you count. If some data you have indicates there's a bit more retail or a bit less. The whole point here is it's $4 trillion of retail in the U.S. in a year, and it is going up, and it's going up pretty remarkably. Keep that in mind. Retail in general is going up. But that's not the thing that's really changing freight. That's certainly changing the volume of freight. But the fact that the fraction of this retail that is e-commerce is increasing as well. So yeah, you heard me right. Retail itself, volume is increasing, and the fraction of retail that is e-commerce is increasing faster. You'll see it's increasing quicker. And everything that you read says both of these trends are going to continue. Who cares? Well, e-commerce orders are small. We are not talking about delivering stuff in pallets. I suspect nobody on this call has ordered a pallet full of anything, maybe in their entire life, but certainly not in the last 6 months, unless it was maybe grass for your yard, which doesn't get delivered this way. It's unlikely that any of us have ordered a pallet's worth of shampoo or shaving cream. Most of us order one item. So we have freight total increase, total retail is increasing, and the fraction of that's e-commerce is increasing, and e-commerce orders tend to be onesies and twosies, not pallets. So my question to you is, how good are you at math? We promise not to have a whole lot of math here, but I got to test you. And so if you want to go on chat, Charlotte will let me know how many people got this right. But here's the question. If you take more sales and a larger fraction of those sales that are e-commerce and lots of those are small orders, what does that equal? A bunch of packages, and they're small packages, and they aren't pallet sized, and they aren't positioned on pallets nice and densely, and they aren't nicely accommodative for forklift travel. And if you think that this was great insight on my part, it wasn't. If you looked at the UPS annual 10K, what's this? 4 years ago, you would have seen average daily package volume increasing, and the rate of increasing is increasing every year. The change from 15 to 16, 4.2, 16 to 17, 4.9. I didn't look at this was the last time I looked at it, but I'll guarantee you, if you looked at the one for last year, it's gone berserk. What about shorter lead times? Well, that's pretty obvious, right? When Amazon and everybody that's in the e-commerce game begins to shorten the lead time, what's going to happen? Well, parcel carriers are going to have to get faster. And how do they get faster? They're happy to deliver things 1 day, 2 days, as long as you pay for it. What do they call it? UPS calls it next day air. Look at this. The increase is next day air 15 to 16 was 4.8%. 16 to 17 was 5.9%. So not only is the amount increasing year over year, but the rate at which that is increasing is increasing. And you go, where's it coming from? We'll look at ground. Ground is increasing, but the rate of increase is decreasing. Guess why? Next day, same day, 2 day from all over the world. It's everything we see is manifest if you know where to look. You can see it in the data if you just know where to look. Last but not least, this idea of many more e-commerce businesses is kind of interesting. This is a chart I grabbed from, some research company. Again, I don't know if this is completely accurate, but it's makes sense. The general trend on this thing makes sense. That the number of e-commerce establishments that are being formed is, this is in thousands. It's talking about over 200,000 little e-commerce And so they are injecting packages into the logistics system at more points. Again, think back to the caveman years, back when I had hair. We were producing stuff in rural areas, putting it on pallets, moving it by filling up 53-foot trucks, moving it to warehouses, into stores. Now we're injecting this, the packages are getting, these little tiny packages are getting injected all over the country. And oh, by the way, what about returns? Well, we now have the fancy term reverse logistics, but it's when something didn't quite work out and we used to take it back to the store, and now you print this mail-in label on your printer and drop it off at a FedEx or UPS store that takes it back somewhere. Just when you got nothing better to do, think about that a little bit. If we're injecting all these packages from all over the country, exactly how is this going to be manifest in the reverse logistics, other than the fact it's going to go up crazy? And how do you handle reverse logistics? That's something else. And oh, by the way, you probably know there are companies out there right now that are set up so that they send you stuff every month, like clothing, and know full well that you're going to send a lot of it back. That's the whole point of the business model. We send it to you. Occasionally you'll keep something and you'll send the rest of it back. So we have got companies that are basing their business model on nearly 100% reverse logistics of the forward logistics. This is seriously stressing the system, folks, and it's doing it right now. We are seeing the cracks. I have some slides when I talk about this sometimes. Just think about what always happens at Christmas, right? Think about Christmas. Some package carrier is late with your Christmas packages and has to promise that they'll do better next time and give you a rebate. And what do they say? Oh, it's not our fault. This happened, that happened, the other thing happened. We'll fix it next year. And they do, but somebody else has the problem. And then they go, not our fault. We had weather delay. We'll do you right. We'll get it there. We'll give you a $50 free shipping, and we won't do it again. So what do? They don't do it, but then it happens again. And so my question that I muse about occasionally is this really each package carrier gets unlucky once every 3 years? Or are we at some kind of tipping point on this thing? And I would submit that maybe we're at a tipping point, and part of the solution, part of the reason is part of the solution. Because currently how we move freight with trucks in particular is pretty inefficient. These are some numbers from a few years back. They are a little better now. I understand these are the last numbers I could find from government statistics, where for truckload transportation, the loaded miles is 75% and empty miles are 25%. Everybody on this call, I am sure, knows that the reason for those empty miles is the way that truckload operations are priced. It's dollars per mile to carry something, and then if you don't have a backhaul, you have to come back empty, or some portion of the trip empty. Those are the empty miles. We are literally getting no value for about 25% of the miles that are traveled in truckload. We travel those miles just to reposition assets. Of the ones that are loaded, they typically max out on weight, or the load's not big enough. And so there's all this unutilized space. Now, that has some implications. Not just, first of all, there's clearly spare capacity there that can help solve some of these problems we've been discussing, but we're also wasting a lot of fuel. So if you are a free market capitalist, you don't like wasting that money. If you're an environmentalist, you're burning all this fuel to reposition assets. You can't like the fact that we are burning about the same amount of CO2 as the country of Poland every year. And if you worry about your fellow humans, there is demonstrably some demonstrable health issues amongst long-haul truck drivers because of the nature of the job and the fact that they're away from home so long and sitting so long and eating not correctly and not sleeping well and all that. So there are lots of impacts to this, in addition to the opportunity that this extra capacity could have for improving the logistics system. One potential solution is collaborative logistics. And this is kind of where we make I hope you will agree with me that this makes sense, because this is where we begin to really look at some of the research that our students have been doing. So as a lead to the collaborative logistics, we're going to break it up into two pieces. One are operational challenges and one are infrastructure challenges. The operational challenges literally say, if we're going to collaborate, we need to be able to have competitors collaborate on the logistics function and still be able to compete. So the question is, how can you do that? How can you encourage people to do that? The second one is, what kind of infrastructure would have to be, how would infrastructure need to be redesigned? And networks be redesigned in order to accommodate a collaborative logistics network, or to have part of the transportation network function in a collaborative way. We're going to start out the research, discussing research that focuses on the operational challenges. So as a preview, before I hand it over to Nathan, consider the fact that there are two types of collaboration. And if you think about a supply chain, this one's relatively easy to imagine. There's horizontal collaboration, which means that entities on the same echelon of a supply chain collaborate. So it's collaboration among carriers, for example, or collaboration among producers. And you go, well, that would never happen. Well, it does. For example, most of the folks who make flat screen TVs actually collaborate on the basic research for the next generation of the type of screen. So they do fundamental research by collaborating because it's so darn expensive. But then once they get the basic findings, they hand it off, and then they compete like the dickens on all the features and the way they implement it. So nearly every level of the supply chain has been known to collaborate. In our case, we're going to look at carriers, and particularly LTL carriers. Vertical collaboration is just that. It's collaborating, say, among producers and suppliers, or retailers and suppliers. So Toyota participating and collaborating with their suppliers is a great example. So here's the setup for carrier collaboration that the first theme of research is going to work on. We have two carriers, and then the facilitator of the collaborative environment is, we're going to call, a central authority. Each carrier receives jobs. An interesting research feature and a contribution of this research is we are allowing each carrier to retain some jobs. So each carrier can look out at the jobs that they've collected and say, I want to keep this one, this one, this one, because they're great customers, and they give the rest of them to a common pool. Then the central authority uses models and algorithms in order to reallocate jobs back to the carriers that they combine with their retained jobs, and then they execute. So there's a fair amount of research that's been done, that we've been doing over the last few years in this particular model. Now, there are three methods, and once you get this straight, then the first two research studies are going to be pretty clear. The three key differences between the three methods that we looked at all pertain to the way that what each carrier is willing to do. And remember, the question we're asking is, how in the world can you convince carriers to collaborate with people that they normally compete with? And so the first question, the first dimension is, are you willing to share revenue from the retained jobs? That is, if you give the jobs up to the central authority, will you share the revenue that comes from serving those customers? The second one is, are you willing to share revenue from the retained jobs? That is, are you willing to give the central authority the ability to take the revenue you get from the jobs you retain and allocate it fairly? Or if you serve those jobs, are you going to insist that you keep that revenue? The other thing that we talk about is, are you willing to give the central authority the locations of your retained jobs so they can do the complete routing? And the last one is, are you in it for the short term and the long term? Are you willing to do this long enough so that you know that if you do a little more work this time, you get a little less profit than you might think you should, because next time out, you're going to do a little less and you'll get a little more. And so those are the three basic combinations of those answers set up the three basic methods that are going to be discussed. Oh, I got to do one more thing and then I'll hand it over to Nathan. I'm sorry, I forgot about this one. And just if you're trying to visualize how this thing works, here are pairs of jobs. So you pick up this job and deliver it here. We have two carriers, green and red, left to their own devices. The green folks do this, the red folks do that. If they collaborate fully, the central authority can do some really kind of interesting things for them and make it very efficient. Hence, you increase profits because you reduce costs. But if they retain jobs and they withhold information or withhold something, you'll get a much less efficient set of jobs, efficient way to handle those jobs. So with all of that, Nathan, study one.
Okay, just as a preview, we actually have 6 studies we're going to present, 4 in somewhat detail, but the other 2 are ongoing work, so they'll be fairly brief. So this is the first study. The lead author here is Maria, my student, and it was published in Translation Letters. Next slide. So this paper focused on evaluating the potential benefits of carrier collaboration in vehicle routing problem with pickup and delivery. So the objectives were to assess the benefit of collaboration among the LTL carriers. LTL stands for less than truckload. And we also did a bunch of experiments to examine what aspects would make the collaboration more or less beneficial. And as Bill mentioned, there are 3 collaboration schemes that we looked at for our entire research. For this paper, we only consider method 1. And method 1, just to recap, there are 3 different 3 characteristics for method 1. The first is that the carriers are willing to share the profit from their retained jobs. Second is that they're willing to release or disclose information regarding retained jobs. The reason we say that because retained job is usually their go-to customers, and a lot of times in practice, they might not want to release or disclose information regarding their customers. And so that's an assumption we made here, that they're willing to release that information. And then third assumption here is that for method 1 is that they are willing to not have the profit correlated with the amount of work performed. Okay, again, in practice, people might feel it's unjust to have a system where you did more work, but you make less profit. But as Bill said, yeah, there's in some cases, sometimes on some days you may make less by doing more, but some days you do less and you make more. Okay, so it will balance itself out. Next. Okay, so in this study, we developed an optimization model, and so I won't go onto the math. I just gave you a very high level description of what we did here. So this is I believe, a mixed integer linear programming model, and the objective here is to minimize cost. Okay, so as any, just go through, we'll go through all the constraints, Bill. So as any optimization model, you have to have a bunch of constraints that make sure that your truck is behaving realistically. So for example, if I look at constraint number 5, it says that we have to ensure that the truck cannot carry more than what it can handle, right? Every truck has like a certain capacity. Constraint number 7, for example, it says restrict the number of hour travel by vehicle route. Again, here by federal regulations, a truck cannot travel over more than X number of hours per day. And so we factor that into our model. Lastly, I mentioned constraint number 9 here, for example. We say every customer or node can only be visited exactly once. And that's something that happens in real life. We don't visit a customer more than once because there's really nothing more to pick up or deliver if you visit that customer the second time. So these are the sort of operational characteristics that we have to consider in our model. Next. And there's just a bunch of other slides, so I'll just, I just want to mention too, constraint number 12, time window constraint. So this is what makes the problem difficult, is that you're trying to identify the optimal route, but at the same time, you have to make sure that when it gets to that node, it has to be within a certain time window. So as you can imagine, if I give you 30 nodes, for example, I ask you, okay, find me the optimal route among these 30 nodes. It's going to take you a long, long time if you think about the different combinations involved. But then if I throw in this wrinkle and say, but by the way, you know, you have to get to this node at this particular specific time window, that makes the problem even tougher than it was without a time window. So this is the sort of constraints that we have to deal with in our model. So to solve for this, you can't use any commercial solver because I don't have the slide here. We took it out because of time constraint. But for even very small problem sizes, you can't use any commercial solver. So therefore, we have to develop our own solution heuristic. And the one we adapted a method called large neighborhood heuristic. And what differentiate this method versus all the heuristic would be is how we take how we determine which nodes should be removed from the route and which nodes, how the node should be reinserted back onto the route. Okay, so here are some results of our experiments. So here, this is the first experiment. The first column here shows you the experiment number. Second column shows you the network size. So we try to figure out, okay, if we increase the network size, how does that impact the average savings? And as you kind of glance through down third column, you see that the average saving doesn't really show any particular trend. Okay, so the point here is that as you increase the network size, it doesn't really impact the average saving. However, you notice here, no matter what the network size is, there's always a significant amount of savings. Next, the next experiment we did was we say, okay, what happens if we experiment? What happens if each carrier retain different percentage of jobs? So you pick any of the three figures shown here, you notice a decreasing trend. And on the x-axis, you have increasing percentage of retained jobs. So that means that, so the result here shows that the more the carriers decide to retain the jobs, the less the savings. Why? Because if there are less potential, there's a less shared job, therefore less potential savings for each of the respective carriers. Next. Okay, the third one, we want to see how we were concerned about the allocation, the fairness of the jobs, right? I mentioned to you, we were concerned that would the carrier be willing to perform more jobs for less profit. So we wanted to see the impact as each carrier retain more jobs, what's the impact in terms of job allocation. So to measure that, we calculate this measure here called ratio, and it's a quotient of L divided by U. L is basically the lowest number of jobs that a carrier gets, and U is the highest number of jobs that a carrier gets. So this ratio indicates the balance or imbalance of the workload between the different carriers. So for example, a ratio of 0.5 means that one carrier has to do twice as much work as the other, whereas a ratio of 1 means that they're doing about the same number of jobs. So if you look at the table on the bottom right, if you just kind of glance through the rows, the columns, you notice that as the carrier retain more jobs, the jobs will become more balanced, which makes sense, right? Because if you and me and Bill are the two carriers, and then we both retain 100% of our jobs, then that means the job balancing would be the ratio would be 1. That means the job is somewhat balanced. I think that's it for the first study, Bill. Okay. Lastly, okay, one more set of results. So here we look at also the impact where the surface area of the carrier have some overlap or not overlap. So on this figure here, if you go all the way to the right, where there's zero overlap. So in the case of zero overlap, the percentage of savings is very low. It's only about 1.58%. Whereas when you have the surface area between two carriers overlap 100%, meaning that exactly at the same area, the potential saving is a lot more, in nearly 25%. And the reason for this is because if you have an overlapping surface area, there are more potential for collaboration, meaning that Bill can help out in some jobs for me, and then I can help out some job for him, depending on my location. So that's how these results makes a lot of sense. Bill.
All right, so as you might expect from the little table we had before, we wanted to compare these different methods. And so I'll translate this as we go through, but at a very high level, let's look at how these things can compare. But first, I want to show you a bit about the way the basic math model that Nathan just described is used as the foundation for all of this work. So as we mentioned in the table, just make it with pictures. Methods 1 and 3, that is where you share the revenue from the retained jobs and the information, as well as in this thing for the long term, and recognize that you might do a little more work and get a little less additional profit one time for the opportunity later on to get a little more. And for method 3, that literally says, I'm going to keep everything about the retained jobs private. A two-step process is used where the mixed energy linear programming model and the large neighborhood search heuristic are used to do the job allocations. And this is the job allocations from the central authority, and build the routes. And then once that is done and we have maximized profit, then some basic elements of cooperative game theory are used to fairly allocate the profit. So you do this first, and you maximize the total profit, and then you pass it off over here, and we figure out what a fair way to do profit is. Whereas in method 2, we want to control the idea here was to control the difference between the percent increase between the carrier that got the most increase in profit and the one that got the least. So we didn't want to have huge winners and losers. We wanted to control that, and we did it within one model that is just a mixed energy linear programming with the large neighborhood search heuristic to solve it. So scenario 1, method 1, this scenario is, like I said, the carrier is willing to do everything. They're going to share the revenue from the retained jobs, share the information on the retained jobs, are willing to do more work for slightly less additional profit this time. Central authority, you do all of the work. So the central authority does the route allocation and building using, it's a direct extension of the model that Nathan talked to you about. And then the profit sharing model is rooted in something called a Shapley factor. That is one of these cooperative game theory solutions. And it does a post-collaborative allocation of the profit. Now, we have to do, because of this approach, you have some mathematical conditions on, there's something called the grand coalition stability, and there's an allocation efficiency. Those are kind of a technical, as my first department chair called them, math voodoo kinds of things. But just believe that they are things that all of us can do if we're given enough time and effort. So in this case, we have the the profit allocation model says, okay, the decision variable is the post-collaboration profit. And the way we get at that is through this auxiliary variable that's defined down here. So the point is, this function here is kind of a nasty looking thing that allocates the grand coalition profit fairly. And the difference between these things is where this little epsilon is, and we want to minimize that epsilon. So we called it Z2 because Z1 is the objective function for the allocation and the route building. This allocates the profit. All right, so it's just again, some mathematical things about stability and efficiency somewhere in here. Yeah, right here. We did all that kind of stuff. All right, wait a minute. Okay, so method 2. Method 2 is there. It is the no. We won't share information on the retained jobs. No, if I do more work, I want to get more profit, but I will tell you where my retained jobs are, central authority, so you can build a better route. In this case, we do the one model that's the mixed energy programming model. And the key features on this one are, since we're trying to minimize this difference, we have to compute, go away. Okay. We have to compute the percentage of increase for the most profitable, and the percentage of, whoops. I'm sorry. All right. And we have to show we have to compute the percentage of increase for the least profitable. This particular objective function is a profit one. We have all these things, but the big feature here is that the difference between the percentage of increase of the most profitable and the least profitable is bounded by this input variable eta. And so in this particular model, we can say we only want when the central authority does its allocating, we want you to do things optimally, but in such a way that the maximum percent gain and the minimum percent gain between carriers is bounded, with the idea that two carriers might get a carrier might get a little annoyed if they consistently made a whole lot more money, relatively speaking, than somebody else. So that's that one. And then method 3 is where.
Sorry, Bill, real quick, we had a question.
Yes.
So from Craig Phillip, he asked that given the chaotic and hyper-competitive environment and the tsunami of investor money pouring into logistics space, is cooperation, collaboration between competitors in the cards for the foreseeable future?
That's all opinion, right? And my opinion is it's going to be. I'd love to talk to you later, but I don't think we can continue to scale the way we're doing it right now. And I honestly don't see any way, unless we start developing part of the logistics space being collaborative, I don't see how we can continue to effectively deliver all this stuff. I know automation is out there. I know we're doing some magnificent things, but the general flood of small packages into a system that was designed to handle pallets, I can't get through my head that we can get there without a paradigm change, at least in part of the logistics network. It's a heck of a question. I have no clue what my crystal ball says, but best I can tell, that's where we got to go.
Hey, Craig, that's a great question. So I want to chime in on what Bill said. I think the partnership between Amazon and USPS sort of give us a crystal ball of what, give us an indication of what might we expect in the future, right? In some way, Amazon, if they could have done that, they will be a competitor to USPS. They would need the USPS, but in this case, they had to partner with USPS to get all the packages delivered, right? But Amazon sort of dictate the schedule where USPS had to deliver on the weekends, right? Which USPS never, was not going to be doing on the weekend, especially on a Sunday, but they had to do that to accommodate Amazon. So I think it's happening already, right? If you look at a partnership between Amazon and USPS. Okay, Bill, just FYI, we're at 2:54.
Okay, so what we're going to do is we're going to show you some results and then move on. We knew this was going to happen. I have a bunch of tables, but I anticipated that we were going to be at this point. So I'm not going to have you look at those tables. For total profit, here's the bottom line. If you share information on and the revenue from the retained jobs, you get the much higher total profits. And we can show analytically and in closed form that the 3 methods, that the total profit for method 1 is greater than 2, that's greater than 3. If you're a little bit greedy, that is, if you want to retain the profit from your retained jobs and not throw it into you actually have to give up something. It's not worth the price, and it could be interpreted if you're really trying to maximize and you're really a little bit greedy, you don't want to keep your retained jobs money. So what seems like a logical way to be greedy is not. If you want to keep your customer locations a secret, it's going to come at a price because the central authority can't make really good decisions on optimal routing. And if you want to be both, the whole pot gets smaller and your portion gets smaller. So, Craig, that's another thing I'm going to tell you is I have great faith in the greed of the American people like me who are running. I'm not running the company, but I'm as greedy as they come. And if I looked at these numbers, I would say maybe I ought to consider collaboration. And I think there's some companies that are going to do that, and we'll see an opportunity here. So Nathan, you've got 2 minutes for study 3.
Okay, I see you did had a question about multimodal. So I think this talk will answer your question. You did. Okay, so I got 2 minutes. So this paper was the first author is Ferrell, Bill's PhD students. It has been published in Transportation Research Record. So I'll fly through this real quick. So here, the goal of this study was to figure out where best to locate or site the intermodal facility. And intermodal here implies that you use more than 2 modes. And that also implies that you don't repackage goods during the transfer process, and then the transfer only occur at the intermodal facility. Next. And so what makes this problem difficult is that we have to consider 5 things simultaneously. Given a set of candidate terminals, we have to figure out the optimal number. And not only that, we have to consider where they should be located and also the mode that should be offered at the different intermodal facility. We also have to consider how those locations of the selected intermodal terminal affect the optimal delivery route. And also lastly, because this is a multi-period model, we have to consider when we should open the intermodal terminal. So that's what makes this problem complicated. And the multi-period aspect and also the multi-commodity aspect was the key contribution of our work compared to prior work. Next. And so we developed a mixed integer linear programming model. And again, the objective is to minimize a bunch of costs. And they consist of, if I can just categorize them, they consist of fixed cost and variable cost. Next. And then, another innovation that we did in this model here is that we consider different commodities or products. And as you know, different commodities have different volume. And so the volume sort of dictate the mode that we had to consider. The other thing we had to consider was the frequency and the schedule of the different modes. For example, it would be unreasonable to have the train go back and forth between origin destination like 10 times a day. That would be unrealistic. So that's another contribution of our work.